super-Earth exoplanet 35 light-years away. Could it support life? A potentially habitable super-Earth has been discovered just 35 light-years away, and it's sparking excitement and controversy among scientists. This exoplanet, located in the L9859 system, sits within the habitable zone of its star, where conditions could allow liquid water and potentially life to exist. The discovery was made by researchers at the Université de Montréal's Trottier Institute for Research on Exoplanets. The exoplanet, named L9859F, is 2.8 times the mass of Earth and follows a nearly circular 23-day orbit around its cool, dim red dwarf star. It receives about the same amount of stellar energy as our planet, making it a prime target in the search for extraterrestrial life. But here's where it gets controversial. Some scientists argue that the habitable zone alone doesn't determine a planet's potential for hosting life. Factors like atmospheric composition and geological activity also play crucial roles. Could L9859F really support life, or are we getting ahead of ourselves? The L9859 system is a compact collection of small rocky planets. By reanalyzing data from powerful spectrographs and combining it with observations from NASA's TESS and James Webb Space Telescope, researchers determined the size, mass, and key properties of all 5 planets in the system. The innermost planet is a mere 84% the size of Earth and half its mass, making it one of the smallest exoplanets measured. Tidal forces could drive volcanic activity on the 2 innermost planets, while the third planet's low density suggests it may be a water-rich world unlike anything in our solar system. This diverse planetary system offers a rare chance to study the formation and evolution of worlds beyond our own. But the real excitement lies in the potential for L9859F to harbor an atmosphere. If it does, telescopes like the James Webb Space Telescope could detect water vapor, carbon dioxide, or even biosignatures. What do you think? Is L9859F a promising candidate in the search for habitable worlds, or are we jumping to conclusions? Let us know in the comments below. 5th planet discovered in habitable zone of nearby star system L9859. Imagine discovering a new world just 35 light-years away, one that could potentially host life. Yet many people overlook its significance. This is exactly what's happening with the recent confirmation of a 5th planet orbiting a nearby star. And the most exciting part? This planet lies within the star's habitable zone, where conditions might be just right for life as we know it. But here's where it gets controversial. The idea that small red dwarf stars like L9859 could be cradles for habitable planets challenges long-held assumptions about where life might exist beyond Earth. Located in the constellation Volans, the star L9859 is a modest red dwarf, but it has become a focal point for astronomers because of its intriguing planetary system. This system has been under close scrutiny, especially since some of its planets are positioned in the star's habitable zone, the region where temperatures could allow liquid water to exist on a planet's surface. Researchers from the Trottier Institute for Research on Exoplanets, IRX, and the Université de Montréal have now mapped this system with unprecedented precision, revealing a total of 5 planets, including one that could be a game changer for future studies. The planets orbit their tiny star at distances much closer than Mercury is to the Sun, which might seem counterintuitive when thinking about habitability. However, the key discovery is the confirmation of L9859F, a 5th planet that does not transit its star, meaning it doesn't pass directly in front of it from our perspective. This planet was detected through meticulous radial velocity measurements using advanced instruments like HARPS and ESPRESSO. Remarkably, L9859F receives about the same amount of stellar energy as Earth does from the Sun, making it a prime candidate for habitability studies. The system's other planets are equally fascinating. The innermost planet, L9859b, is a sub-Earth, roughly 84% of Earth's size and half its mass. Its neighboring planets might experience volcanic activity driven by tidal heating, similar to Jupiter's moon Io, which is known for its intense volcanic eruptions. Meanwhile, the 3rd planet appears to be a potential water world, with a low density indicating a composition rich in water or ice. The nearly circular orbits of these planets make them especially suitable for detailed atmospheric analysis, as stable orbits help scientists better understand their atmospheres. René Doyon, a co-author and director of IRX, emphasizes that the diversity of planetary types within this system makes it a natural laboratory for answering some of the most pressing questions in exoplanet research. These include, what are super-Earths and sub-Neptunes actually made of? Do planets around small stars form differently than those around larger stars? And crucially, can rocky planets around red dwarfs retain their atmospheres over billions of years? And this is the part most people miss. The confirmation of L9859F's existence was achieved without new observations. Instead, scientists reanalyze existing data from space telescopes like TESS and JWST, combined with ground-based instruments such as HARPS and ESPRESSO. Using innovative techniques like a line-by-line radial velocity method and a new temperature indicator, they managed to filter the strains of stellar noise and refine their measurements. This approach doubled the accuracy of previous estimates for the planet's sizes and masses, demonstrating how powerful archival data can be when analyzed with cutting-edge tools. Looking ahead, L9859 is poised to become a cornerstone in the study of rocky exoplanets. Its diverse planetary makeup and close proximity make it an ideal target for atmospheric characterization with the James Webb Space Telescope. The IRX team has already begun follow-up observations, and soon L9859 could join the ranks of systems like TRAPPIST-1, offering invaluable insights into the formation, composition, and potential habitability of planets orbiting small stars. In conclusion, the discovery of this fifth planet, especially one in the habitable zone, underscores how much we still have to learn about our universe. It challenges us to rethink where life might exist and pushes the boundaries of our technological capabilities. Do you believe planets around red dwarfs could be just as hospitable as those around stars like our sun? Or is this a false hope? Share your thoughts and join the conversation, because the universe is full of surprises, and we're just getting started. Unveiling the L9859 system, a fifth exoplanet confirmed in the habitable zone. Exciting news from the cosmos. Astronomers unveil a fifth exoplanet in the L9859 system. In a groundbreaking discovery, astronomers have confirmed the existence of a fifth exoplanet, designated L9859F, within the intriguing L9859 system. This newly identified planet is classified as a non-transiting super-Earth, boasting a minimum mass of 2.8 times that of Earth and orbiting its host star every 23 days. Comfortably nestled within the habitable zone of the small red dwarf star known as L9859. An artistic representation of the L9859 planetary system showcases the habitable zone super-Earth L9859F prominently in the foreground. Credit for this captivating image goes to Benoit Goujon from the Université de Montréal. The star L9859, also referred to as TOI-175 or TIC30210830, is an M-dwarf star that possesses only about one-third the mass of our Sun. Located approximately 34.5 light-years away in the southern constellation of Volans, this system has garnered significant attention from astronomers. Previously, in 2019, the Transiting Exoplanet Survey satellite, TESS, identified 3 transiting exoplanets within this system, which orbit their star in compact cycles of 2.25, 3.7, and 7.45 days. Additionally, an outer planet with a 12.8-day orbit was confirmed in 2021 through the use of the European Southern Observatory's ESPRESSO spectrograph. These planets vary in size from 0.8 to 1.6 times the radius of Earth, with masses ranging from 0.5 to 3 times that of Earth, and they likely possess a variety of compositions, from Earth-like to potentially water-rich. In a recent study, astronomers Charles Cadieux from the Université de Montréal and his colleague undertook a meticulous reanalysis of data from TESS, ESPRESSO, HARPS, and the James Webb Space Telescope. Their efforts led to an unprecedented level of precision in determining the sizes and masses of these planets. We have refined the radii of L9859b, C, and D to 0.84 Earth radii, 1.33, and 1.63 respectively, they reported. We also present updated mass estimates of 0.46 Earth masses for L9859b, 2 for L9859c, and 1.64 for L9859d, along with a minimum mass of 2.82 for L9859e. The confirmation of the fifth planet, L9859f, located in the star's habitable zone, is particularly thrilling as it suggests conditions that could support the presence of liquid water. Dr. Kedja expressed his enthusiasm, stating, "Discovering a temperate planet in such a compact system makes this finding especially exciting. It underscores the incredible diversity of exoplanetary systems and reinforces the importance of studying potentially habitable worlds around low-mass stars. With these new findings to provide the most comprehensive understanding we have ever had of the fascinating L9859 system," Dr. Kedja emphasized, "this is a powerful demonstration of what can be achieved by integrating data from space telescopes with high-precision instruments on Earth. And it highlights key targets for future atmospheric studies using the James Webb Space Telescope, a collaboration between NASA, ESA, and CSA. The refined measurements indicate that the inner planets have nearly circular orbits, a configuration that is favorable for future atmospheric detection efforts." Professor René Doyon, director of the Trottier Institute for Research on Exoplanets at the Université de Montréal, remarks, "With its variety of rocky worlds and diverse planetary compositions, L9859 serves as a unique laboratory to explore some of the most pressing questions in the field. What materials make up super-Earths and sub-Neptunes? Do planets form differently around smaller stars? Can rocky planets orbiting red dwarfs maintain their atmospheres over time?" The research team's findings will be published in the Astronomical Journal, further contributing to our understanding of this remarkable planetary system. What do you think about the discovery of L9859f? Do you believe that planets in the habitable zone of red dwarfs can support life? Share your thoughts in the comments below. Reference, Charles Cadua et al., 2025. Detailed architecture of the L9859 system and confirmation of a fifth planet in the habitable zone. AJ, in press, RXIV 2507.09343.